augmented reality, and mobile vocational training. Augmented reality is a context-sensitive emerging technology that projects an interactive layer of virtual information onto a real environment or object, enabling users to deepen their understanding of the real world. For example, using an AR app, I could point my phone at a building on the street and see the building on my screen overlaid with information on its architectural features. Augmented reality has some unique affordances that are well suited to teaching and learning. Learners interacting with real objects and environments enriched by AR can collaborate with others to actively create their own knowledge. In the classroom, AR can be used to set up authentic situations and problems, provide scaffolds, facilitate participation, and for peer coaching. This has the effect of making learning more meaningful for the student. Assessment could also be embedded into an AR app. To date, augmented reality has been used for consumer products such as gaming and advertising, and in educational contexts such as environmental education, virtual field trips, museums, medical, and vocational training. This presentation will explore augmented reality's educational potential in workplace instruction, in which mobile technologies play a major role in helping people gain professional training or are supported with real-time instruction to do an aspect of their job. These types of augmented reality applications are coming into their own now as they are paired with new wearables such as smart glasses with improved tracking and sensing technology. These hands-free devices enable learners to focus completely on accomplishing the task in front of them while receiving instruction. Vancouver-based company Engrain produces software for industry training and work environments like manufacturing, aerospace, oil and gas, and mining. Using a mobile device held up to a piece of complex machinery, users can receive just-in-time, visually based 3D instruction on how to assemble or repair that machine, as well as enterprise information such as inventory and work orders and live help. Engrain software also has diagnostic capabilities which would support apprentices without one-to-one supervision and remote workers without specialist mechanical training such as pilots to receive instruction on maintenance and repair procedures of their equipment. New wearable devices such as Microsoft's HoloLens and Epson's Moverio BT200 smart glasses will open up vast potential for AR, as will Engrain's partnership with Z-Space, makers of advanced head and stylus tracking technology. The Engrain Z-Space venture is a medical application that will turn actual patient data such as MRIs, CT scans, and ultrasounds into visual 3D information that physicians can explore from every angle so they could see, for example, how a tumor is exactly situated. By gaining more visual information prior to invasive procedures, physicians can make a better plan as to how to approach the problem. One criticism of augmented reality is that it provides too much information at once, producing cognitive overload. This effect can be minimized by providing training on how to use an AR app and by starting simply and building up to more complex tasks. Well-designed applications could minimize this effect by giving users control over the amount of information they see at any given time. As well, presenting media in multiple modes, for example, audio support for text, could help reduce confusion. Another limitation to wide adoption in education is that augmented reality resources are relatively time-consuming and difficult to make, and sometimes YouTube provides just as good of an instructional solution. Some companies like Engrain are aiming to make more user-friendly software so that organizations can create their own training materials, including animations, without having to know any code. One of the biggest limitations to widespread deployment of instructional augmented reality is that 3D models on which the instruction is based come in a multitude of file formats. Those formats need to be converted into usable augmented reality models before any instructional design can take place. Third-party software is most often needed, but even then it's not a turnkey solution. This can be a bottleneck because industries have thousands of models that they need to convert before beginning instructional design. Companies deploying augmented reality-based training would need to make a significant investment to create instructional animations for industrial environments. The scope of a project like this would be time-consuming and costly. But with new wearable technologies, long-term efficiencies, and potentially